Okay, so moving on to the next topic for KIT 257 is on electrical properties. Probably today, just a very simple introduction before we are going to detail next week. So, part of the important things in materials is basically to understand the electrical behavior. Whenever you produce a material, it is also important to understand whether the material exists electrical properties or not. Okay, for example, if you produce metal, you know that iron or pure metals will actually give conduction. But when you produce alloy, because you actually dope with different types of elements, if you produce composite, you dope it with different types of salts, and the salt could be sometimes conducting or non-conducting, then you just want to know whether the materials can actually have electrical conduction or not. So things that you need to understand in this chapter is how materials can conduct electricity. How electrical conductance and resistance can be characterized. Okay. What are the physical phenomena that distinguish conductors, semiconductors, and insulators? So what does it mean by conductors? Conductor, it means that the material that can conduct electricity. Okay. So when you put source, you apply potential to the materials, the electrons can actually mobilize. It can actually move in the materials, and this will give the conduction. Semiconductor, it means that the material have a slight electrical properties. It can conduct electricity, but with a very minimum amount of electrical value. And insulators, of course, we know that this material, it didn't conduct, I think, electric as compared to conductors and also semiconductors. For metal, how is conductivity affected by imperfection, temperature, and deformation? Imperfection means that when you dope with different types of impurities, imperfection, you actually put other elements in making it alloys as a, maybe tough materials. But at the same time, how do we actually look at the conductivity? Temperature is another example. If you increase the temperature, what's going to happen with the electrical properties? Either it's going to increase or also decrease. And finally, deformation. If you actually put some stress to a material when it deforms, okay, so what would be the electrical properties? Is it going to be similar or is it going to be different? And for semiconductor, how is conductivity affected by impurities, by doping and temperature? Okay. So for electrical properties, part of the examples of materials that we can see available around us is from your identity card, or maybe from other circuit boards, from your phones, from your laptops, and others. So the scanning electron micrograph of an IC, so IC is actually integrated circuit, not identity card lah. IC is actually integrated circuit. In integrated circuit also available in your IC. You can see in your IC there's a chip. So this is actually integrated circuit. Those days people use board. They use wires and everything. But now they just use small chips, maybe integrated circuit board. So all these are actually printed materials. You have a conductors, aluminium, silicon, and others, which actually give the conduction to the material. So it then requires a very huge device. Kalau nak store you can see how much the information can be stored. With your IC, identity card, you can use it as your ATM card. You can use it as touch and go. You can use it for identification and others. So how incredible this storage of integrated circuit have been. Otherwise, maybe back in 50s, back in 60s, we wouldn't have this kind of things. And maybe if you want to store the information, you have to store in a bulky, bigger materials. So a dot map showing the location of silicon, a semiconductor, okay, and a dot map showing the location of aluminium as a conductor. So these two materials is the same. It's just that you have a secondary SAM image where one is actually can show where does the semiconductor silicon dope is, and then another one is where is the conductors, right? One of the most important characteristic of solid material is the ease with which it transmits an electrical current. When electrical potential is applied across a piece of material, a current of magnitude flows. So when you have, I think, potential, as I told you, okay, when you have a potential, okay, and when this potential has actually been applied, to an object and specimen, okay, so what happens is that the electron will be moved, and the movement electron will produce current. So people still didn't understand what does it mean by current. Current is actually produced by the flow of electrons. So that is why in physics you have learned that in the Ohm's law, potential is equals to current multiplied with resistance. Okay, V is equals to IR, where V is actually the potential in voltage, I is actually current in amperes, and R is actually resistance in ohms. The resistance is depend in the intrinsic resistivity. Okay, rho. So rho is actually intrinsic resistivity of the material and the geometry, which is the length, area A, shape, and the properties of a material. A smaller cross-sectional area or longer length means the resistance will increase, thereby decreasing the current flow. Okay. So if I ask you, okay, imagine that you have a two types of rod. You have a two types of metal rod. You have one that is around 10 centimeter, another one around 2 centimeters. Which one do you think that will be more conducting? Soalan senang. Antara two metal rod that is 10 centimeters and another one is 2 centimeters. Which one have, I think, quite high value of conductivity? Siapa nak try? Yang ni saya pun tak tahu nama dia. Letak nama dia Nur aja. Adakah? Nur. Nur, are you there? Tak ada dah. Tak ada Nur dah. Okay. Alright. Hafizah Adibah. Hafizah ada tak? Hafizah senyap juga. Oh.
Yes, Doctor.
Ada pun. Oh, finally. Saya ingat tak ada tadi. Okay, so Hafizah, antara dua metal rod, you have 10 centimeters and 2 centimeters. Which one do you think that will have bigger conduction? Senang. Budak-budak boleh jawab. Macam mana?
10 centimeter.
10 centimeter. Okay, thank you very much Hafizah for trying. Okay, so nak tanya Fatin Nurdini. Fatin ada tak? Fatin, are you there? No, okay. Gary, are you there, Gary? Gary Tian.
Yes, doctor, I'm here.
Okay, right. So Gary, are you agree with that answer? Do you think that 10 centimeters will give a higher conduction as compared to 2 centimeters?
I think so.
Okay. Based on the, I think, the one that been explained just now, I mean, from this. Okay, so you have a statement saying that a smaller cross-sectional area or a longer length means that the resistance will increase, thereby decreasing the current flow. You still agree, Gary?
Not so sure.
Okay, never mind. Liu Lijing, are you there?
Yes, Doctor.
Okay, Lijing. So what do you think? Do you think that 10 centimeters steel rod will give higher conduction as compared to 2 centimeters? Do you agree with the previous answer, Li Jing?
Yes, Doctor.
You agree? Okay. All right. So the answer is actually no. The one that has a shorter length will give higher conduction. So why? Because if you imagine if you have a material that has a longer dimension, long, then it will take more time for the electron to reach another end, one end to another end. So it will be more resistive, and this will give a lower conduction as compared to a shorter rod. So 2 centimeters with 10 centimeters, obviously 2 centimeters will give the higher conduction as compared to 10 centimeters. Of course, in terms of the value, it's going to be the same. But which one is the fastest? Of course, 2 centimeters will be the fastest because it's actually the shortest. Okay, right. So we can look from this. Oh, not yet, I guess. Maybe later. So resistivity. So what does it mean by resistivity? Rintangan. A material properties that is independent of a sample size and geometry. Intrinsic resistivity rho is equals to resistance multiplied with area over the length. Okay? And electric current results from the motion of electrically charged particles in response to forces that act on them. Most solid materials like metal, the current is carried by electrons. Ionic materials like crystal, the charge carrier are ions. Okay, and the net motion of charged ion that produce the current. Meanwhile, conductivity. So conductivity, what does it mean by conductivity? Conductivity means that the ability of a substance to conduct electric current. So it is actually inversely proportional to resistivity. If you have a higher resistivity, it means that you have low conductivity. So if you have less resistivity, then you have higher conductivity. So this is actually to explain the examples that I've told you. When you have like two different roads with a two length, 10 centimeters and 2 centimeters, 10 centimeters will actually give you a slightly higher resistivity as compared to 2 centimeters. Then when you have higher resistivity, that it means that the conductivity will be slightly lower. Okay, so classification based on conductivity values. Of course, in order to identify whether the material is conductors, semiconductors, or insulators, it is actually depending on the value of conductivity that the material produce. For conductors, normally it should be above 10 power of 5 Siemens, ohm over meter. Semiconductors, it should be around lower than that, 10 power of 5 to lowest one, 10 power of minus 6 Siemens or ohm over meter. And finally, insulator, anything that is lower than 10 power of minus 6, 10 power of minus 7, 10 power of minus 8, minus 20, or whatsoever. So all this can be categorized as insulator. Okay. Uh, Maybe a last one before we end our lecture. So power, what does it mean by power? So when the current flows through a resistance, so power is equals to voltage multiplied with current. Okay. And when you actually integrate this, when you combine with Ohm's law, then you will have power equals to current square multiplied with resistance. Higher resistance will result in larger power losses. A second form of Ohm's law is obtained if we derive the equation to give this variation, okay, where current over area is equals to flux. Sigma is now considered as conductivity of flux. Okay, conductivity multiply with voltage over length. Okay, and this can be easily simplified as J. J is actually current density. So remember current density. I think later on you will learn this in the final topic in corrosion. Okay, you will hear about current density. So current density J or small I is actually current over surface area. Current divided by area is actually equals to current density. Current alone is I. Current density is over area. Okay, so the current density is actually equals to conductivity multiplied with the voltage gradient. Right, so for the examples, I guess maybe we are going to look at it next week, next Monday. Okay, so at least today we have been defined slightly what does it mean by electrical conduction, some basics of Ohm's law, resistivity, and conductivity. Okay. Is there any question before I end the lecture? Right. So I will stay back if you have further question with regards to your assignments or anything. So if no further question, then I will adjourn the class. Thank you very much for your kind attention. Hope to see you next Monday, and hope you guys enjoy your weekend. So thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Goodbye all.
Thank you, Ada.
You're welcome.
Yeah, that's
Welcome.